All right, let's get started. Hey, everybody. So yeah, my name is Andrew, software engineer at Microsoft/LinkedIn, previously with Snapchat, IBM, BlackBerry in Silicon Valley area. I'll be your instructor for this course, Software Engineering Interview Prep. If you're targeting a software engineering role at the top tech companies, I highly recommend you attend this course. This course is absolutely for free. We will cover everything from software engineering to technical data structures and algorithms to go-to-market strategy. So during this course, I'm going to be covering important topics, most asked interview questions, and efficient ways to solve them. So I have more than 6 to 7 years of experience in software engineering role at top tech companies in the United States. And I have helped a lot of candidates with interview preparations. I'm very excited to help you land your dream role. So sign up for my course, and I look forward to meeting you in the sessions. So let's go over the structure. Let me give you a very quick overview of HiCounselor. HiCounselor is an online career accelerator which helps job seekers find full-time jobs. HiCounselor helps candidates with interview prep as well as getting the interview calls. So we utilize artificial intelligence-powered job search algorithm and strong network of 300 plus employers to help candidates like yourself land a job. So every candidate get personal attention and mentorship from professionals like myself who come from top tech companies. So the payment structure at HiCounselor is income share agreement where you don't pay anything to HiCounselor until you land a job. So once you find a job, you pay a fraction of your first year salary in installments. So there's zero upfront payment. By the way, my camera is broken, so I'm going to be fixing it before the next session. So for this course, I'll just be sharing my screen. And if you're looking for a job, HiCounselor could be a very, very good resource for you. The next cohort at HiCounselor starts very soon. So if you're interested, please apply on HiCounselor.com and feel free to use my code Andrew, ANDREW. You will get a $500 discount when you start paying HiCounselor after landing a job. That's ANDREW. Okay, so for this session, we're going to be going over a graph and how graph is used in the coding interview questions and technical interviews. So what is a graph? So graph is a non-linear data structure that comprises nodes and edges. So basically, the nodes or sometimes called like brokers in more specific use cases in systems engineering. Nodes are sometimes also referred to as, vertices and the edges are lines or arcs which connect any two nodes in the graph. So basically, graph, finite set of nodes and set of edges that connect a pair of nodes. Okay. So let's give you an example. In this graph, the set of vertices 0, 1, 2, 3, 4, right? So these are the nodes, and the set of edges are 0, 1, 2, 3, 1, 2, 3, 4, 0, 4, 1, 4, and 1, 3, because these are edges or lines that connect these vertices. So graphs are actually utilized to solve a lot of real-life problems. It's one of the most applicable algorithm and data structure component that is used in real-life engineering. So graphs are used to represent networks. So you can see how networks and graphs can be utilized for many, many actual complex problems in the world. And the networks may include paths in a city or telephone network or a circuit network. And graphs are also used in social networks like LinkedIn, Facebook, and you name it. So for example, in Facebook, every person is represented with a node or a vertex, which is a singular form of vertices. And every node is a structure and contains information like the identifier of the person, the name, the sex, the locale, etc. Okay, so let's start with a very simple question. So we know that graph is a data structure that that consists of couple of components. Number one, this finite set of vertices, also called as nodes, and finite set of order pair of form called as edge. All right. So these two are the fundamental characteristics. Now, the graphs are used to represent, as we mentioned, many life applications, and typically two terminologies are most commonly used in representations of graph: adjacency matrix and adjacency list. So the choice of graph representation is situation specific. It totally depends on the type of operations to be performed and ease of use. So the adjacency matrix is a 2D array of size VXV, where V is the number of vertices in a graph. Let the 2D array be AD, and a slot AD at I and J indicates that there is an edge from vertex I to vertex J. So adjacency matrix is for undirected graph is always symmetric. Adjacency matrix is also used to represent weighted graph. So if AD at I equals I and J equals W, then there's an edge from vertex I to vertex J with the weight of W. So let's try. Actually, yeah, before moving on, let's look at some of the subtopics that are most commonly asked in interview questions. So it's called DFS, depth first search. So depth first search or traversal for a graph is very similar to depth first traversal of a tree. The only difference is that unlike trees, graphs may contain cycles. A node may be visited twice. So to avoid processing a node more than once, we can use a Boolean visitor array. Okay, so let's look at BFS, which is breadth first search. So BFS for graph is similar to breadth first search traversal of a tree. The difference is that graph may contain cycles again, and to avoid processing a node more than once, we can use a Boolean visited array. And for simplicity, it's assumed that all vertices are reachable from the starting vertex. So, for example, in this graph, we start traversal from vertex 2. So when we come to vertex O, we look at all adjacent vertices of it. So 2 is also an adjacent vertex of 0. And if we don't mark visited vertices, then 2 will be processed again, and it will become non-terminating process. So the breadth first traversal of the following graph is 2, 0, 2, 0, 1. Sorry, 2, 0, 3, 1. Okay, so the breadth first traversal of this graph is going to be 2, 0, 3, and 1, because it's a breadth first search. So let's do one more example. let's look at depth first search. And there are a couple interesting problems within DFS as a building block. So number one is detecting a cycle in a graph. So a graph has a cycle only if we see a back edge during depth first search. So we can run DFS for the graph and check for back edges. Number two is path discovery. We can specialize the DFS algorithm to find a path between two given vertices U and V. So we use stack to keep track of the path between the start vertex and the current vertex. So as soon as the destination vertex is encountered, we return the path as the contents of the stack. Okay, so let's do one simple question. So the problem is as such. We have an undirected star graph, okay, consisting of n nodes labeled from 1 to n. So star graph is a graph where there is one center node and exactly n-1 edges that connect the center node with every other node. So again, star graph is a graph where there's one center node and exactly n-1 edges that connect the center node with every other vertex. So you're given a 2D integer array called edges, where each edges at I indicates there is an edge between a nodes U and V. So we have to find the center of the given star graph. So for example, let's say we have this. If we have an input of edges 1, 2, 2, 3, 4, 2, the output is going to be 2, right? Because as shown in the figure above, the node is connected to every other node, so 2 is the center. So let's come up with a algorithm that can solve this. So we'll be back, and then I'll let you think about it for a couple minutes, and then we're going to be solving this problem together. Okay, so let's take a look. So we are already given edges, and the edges is a 2D integer array that tells that there is an edge between nodes u and v, and we want to find the center of the given star graph. So in Java, what this would look like is you have x, which corresponds to the very first, and then we have y, which corresponds to edges at I equals 0 and y equals 1. So there will always be a center. So if checked using a O of n loop for the count of both first row element, we can pull this trick. So let's say you have center method, and you have edges as the argument. So int x is going to be the very first, and then int y is going to be edges. At 0 and 1. Okay, so this is going to correspond to the very first coordinates x and y value. Okay, and then we essentially check if y is equal to we essentially check if y is equal to edges at 1 and 0. And there's going to be a second condition as well. Which is that dy is also, or y is equal to edges at 1 and 1. So if this is the case, then we return y. If that's not the case, we return x. So what we did is we checked if the y is equal to the first pairs x, or if y is equal to the first pairs y, right? So in this case, it's going to be for the first condition y, which is 0 and 1, 2. So if 2 is equal to 2, right? Or we check if 2 is equal to 3, right? So because one of the conditions satisfy, we can return y, which is going to be 2. Else, we just return x. So what's another way to solve this? So another way to solve this is into one line, which is basically a shortened version of this code. But what's the intuition? So we know that given the conditions, all we need to do is compare edges 0 and edges 1, right? So we only need to compare the edges at the first, the 0th pair and then the first pair, because that's the condition and that's all we need to find the center of the given star graph. And we know that complexity is going to be time complexity of O of 1 and the space complexity of O of 1. So what was the solution? We checked whether the first pairs, we checked if the first pairs y value is equal to the second pair's x value, and whether y is equal to the second pair's y value. So in that case, we just returned y. So let's do a second question. And it's also a very similar question. So we have a bi-directional graph with n vertices. Each vertex is marked from 0 to n minus 1, inclusive, and the edges are represented as a two-dimensional integer array edges. So edges at I denotes U and V as bi-directional edge between vertex U and V. So every vertex pair is connected by at most one edge, and no vertex has an edge to itself. So find if there is a valid path that exists from vertex start to vertex end. And given edges and the integers n, so given edges and integers n, start and return true if there's a valid path from start to end. Okay, so let's do an example. An example is here, and we know that the input is 3 and the edges are 0, 1, 1, 2, 2, 0. Start with 0 and end in 2. The output is going to be true. Why? Because there are two paths from vertex 0 to vertex 2, which is 0, 1, 2, and 0, 2. So let's implement this and let's come back when you think about it, after you think about it. Okay, let's try to tackle this. So you want to find if the path exists in this bidirectional graph with vertices and the edges are labeled in 2D integer array edges. Okay. So there are many solutions to this. We can do BFS. We can do DFS. We can do disjoint set. However, for the sake of this problem, we're going to go with DFS using stack. So we're going to tackle this using recursive DFS and then take it from there. And for this one, we can try in a different language. So here, we took an iterative depth first search using stack data structure, and we went ahead with using on-order map, iterating through all the edges and pushing the individual edges to the graph. And as long as the stack was containing something, we compared the top and end, and then if that was the case, we returned 1. And for every node in that graph to the top, we checked if that node was visited. And then if it wasn't, we marked it as 1, and then we pushed the node to the stack. So another way to solve this is using BFS. So we form a graph and check if the path exists, which is a basic breadth first search. And then the last way to solve this is disjoint set. So in this case, we don't really need to find the length of the path. Because this is an undirected graph, you just need to verify if the start and end are in the same connected component. So you can just use a union find. Okay, so I want to leave you with some problems to take away and try to solve on your own, because graph is a very extensively frequently asked question in a coding interview or tech interview, especially in FAANG companies that are a big interview department. So one assignment that is doable is, how do you come up with how do you come up with breadth first search without using a queue? So that's the question I wanted to leave you with. So BFS without utilizing queue data structure. So you want to do BFS for graph implementation using adjacency list without using a queue. So for example, you have this graph, and the output is going to be BFS traversal, which is going to be 2, 0, 3, and 1. We start the traversal from vertex 2, and when we come to vertex 0, right, we look for all adjacent vertices to it. 2 is also adjacent vertex of 0, and if we don't mark visited vertices, then 2 will be processed again, and it will become non-terminating process. So the breadth first traversal of the following graph is 2, 0, 3, 1. So so basically, this problem can be solved using simple breadth first traversal from a given source, and you want to use adjacency list representation of graphs. So I want to let you solve it on your own and take away assignment, and then the hint is that the time complexity is going to be O of V plus E, where V is the number of vertices and E is the number of edges. So you want to do a BFS without using a queue. Okay. So as we wrap up, I wanted to go over the HiCounselor one more time. HiCounselor is an online career accelerator which helps job seekers, which I was at the beginning of my career, to find a full-time job. HiCounselor really does an amazing job in helping candidates with interview preparations, recruiter calls, and technical preparations, as well as getting the interview calls and emails. So they utilize ML, machine learning powered job search tool, and a very tight network of employers to help candidates land a job. So every candidate gets personal attentions and mentorships like professionals like myself who come from top tech companies. As mentioned before, the payment structure at HiCounselor is ISA, where you do not pay anything to HiCounselor until you find the job. And then once you do, you pay a fraction of first year salary in installments. So there's nothing upfront. So if you're looking for a job, HiCounselor could be a great resource for you, even on top of these technical coding questions, but also how to actually approach recruiters and how to actually tackle your soft skill questions. So next cohort, HiCounselor starts soon. So if you're interested, please apply on HiCounselor.com. Feel free to use my code Andrew, ANDREW, and you will get a $500 discount when you start paying HiCounselor after landing the job. So I wanted to thank you very much for your participation and attention. Again, if you need assistance with job search, HiCounselor could be a great resource for you. So as you mentioned, the payment IFA, and you'll get a $500 discount when you use the code Andrew when you start paying HiCounselor after landing the job. So go ahead and write down this question: BFS without utilizing Q data structure. So breadth first search, and you want to do in a time complexity of O of E plus a V, and then feel free to use other data structures except for Q. So I wanted to thank you, and I'll see you in the next session.